Hello again. Today I'm going to be taking a look at the crosshead, and that is supplied as this casting. This is the crosshead and this is the eccentric strap, and I've left these joined together for a while because I was considering using the eccentric strap to hold this to work on it, but I don't think that's actually a very good idea. So I think what I intend to do is cut that off there. Now, when you look at what we have to do here, we have to machine this face. That's this one. Bring that in. And then this tapped hole and this bore have to be perpendicular to that face. That's very important. And then there's a diameter that's machined on the outside of this part, and that must run concentric to this feature, and this feature has to be aligned centrally to those. So I think what my plan is going to be to dust off these surfaces, which are non-critical, same the other side, and those are just to provide me reference surfaces to clamp the part, and then I can hold this in the vise, machine this, drill and tap that hole accurately, and then I can use that to hold it in the lathe to turn this OD. And I think what I'll do in order to hold it, I will actually make a large diameter boss, because then I can screw this tight against that boss and give it some really good support. And then once I've machined this OD, it will be quite simple to go back to the mill, make this face and accurately position this hole. So that's my plan. And then there are some other features, some angled holes which are, and some through holes which are oil feed holes, fairly non-critical. We will add those in as we go. So that's the plan. Now, before making this judgment, I have measured this casting, and I've established that the alignment of these faces as they are to this, to the center of this, and to this inner kind of feature, run out about 10 thou. Again, another PM Research casting that is quite accurately made, and so they make life very easy for you that way. So what I will do is dust these faces off to get them equidistant to the center of this, and then these will be the features that allow me to start controlling everything else. In the engineering world, you'd have some geometric dimensioning and tolerancing on this drawing to sort of dictate the relationship of these features as it is in the model engineering world, and this is very normal, is you have to figure out what's important for yourself. This runs up and down inside the frame casting in a bore, and is connected to the piston with this tapped hole. So that's how I understand that the center of this hole has to be critically aligned to the center of these. So there you go. That's the plan, such as it is. Less talk, more machining. These surfaces have all been machined now, brought back so that the thickness here is even relative to the center of this, approximately, within 10 thou anyway, which is plenty good for this. I've squared this up just by eye on the line formed here, so that I know that when I drill and tap this hole through, it will go squarely through the casting. And now I'm going to machine this surface, and I'm just going to go to minimum cleanup because the part is actually already shorter than the dimension on the drawing. However, the full length of the part is not super critical. It's really the face of this to the crossbore that goes in that's important. So, but I'm just going to remove the minimum material I can just to clean the whole face, because I'm going to use that whole face to support this in the lathe. Here I'm using a gauge pin the same diameter as this inner feature to establish the zero. Now, I have not disturbed the part from the setup since machining the top flat. It's very important that the hole that goes in is perpendicular to this surface, so that has not been disturbed. And I'm just using the gauge pin to get the zero centered, and I'm doing it by excuse me, feel. And you can quite accurately just by feel, by using a gauge pin that's the same as the diameter as the top of this boss, you can get that feature centered. That's really just important from a visual aspect, so that when the part is finished, the rod that goes into this part is in the center of this feature here, and then from there that will allow us to establish the outside diameter of this, and from there the location of other features. So, you know, being a casting, this is sort of slightly uneven around some of these surfaces. That's just the nature of the thing. So we just get the starting position as close as possible to this, so that the tapped hole is in the right place. Then everything else will follow from that. Over to the lathe and see what I've got here. This is just a piece of aluminum bar, round bar, rod, and has a 5/16 18 hole tapped in the middle of it. And the face is faced off square. Now, this has not been disturbed since facing this off and drilling and tapping this hole and putting this stud in it. So the idea is that this face is perpendicular and on center to the axis of the machine, so that when I attach the cross slide, I can spin that up and do it up nice and tight. And now when I turn this OD, that will be concentric to that tapped hole. That's the plan. So I'm going to tighten this up a bit more and then we'll get on with it. I measured this before starting, and I know that there's like 125 thou to come off the diameter, so let's see if I can take off enough in this pass that I can start getting a measurement. We're on the money there. Shooting for 1.508 because the bore in my frame went oversize, so I'm matching this to that. And it's 1.5077, so we're right on. Got the part clamped to a tool plate. I indicated across this face to get that square and in line with the y-axis of the machine. Oops. I have a gauge pin in here. This is the tightest gauge pin that will fit in there, and I've used that with a feeler gauge to establish the height of the end mill over the center line of the part. And I've then programmed the DRO with that so that I know where the end mill has to end up to achieve the spot face I need in that area. And I've used edge finders to find center of the part from this diameter, which was turned by holding relative to this face and that tapped hole. So I'm in good shape to be able to plunge, mill and get my spot face. I'm using a 3/4 inch end mill. The print calls out for a 7/8 inch diameter spot face. So I'm going to do what I can with this, and if I need to clean up any more, I will use my boring head. But right now I want to establish the height of that spot face and flatten this area so that I can then come and drill and ream the through hole. I've established that the the end of the connecting rod that mates with this part is well under 3/4 of an inch in diameter, and so I'm not going to spend a lot of time making this a 7/8 inch spot face because it's going to fit as it is. So what I am going to do is simply bring the end mill back down and then move the table in the X direction and just clean out that spot face. There's a little ridge here, so I'm just going to clean that out. So away we go. Final phase for this side is to drill and ream the through hole, and I'm going to do that now. I then have to flip this part. The through hole could potentially be used for alignment on the second side, but the fact of the matter is these pockets are not critical in their location except for relative to the vertical center line. Anyway. That's it for this side. Now to turn it over. I didn't film the machining of the second pocket. That was the same as the first. So that's complete. Part is now set back up, resting on parallels to keep this edge straight and clamped between these 1, 2, 3 blocks. Next part is a 3/32 oil hole, which has to go all the way through. So it's now just a matter of establishing center line here, piece of cake with the half function, and then then establish this face, move back here 9/16, center drill and drill through. Just about enough length on the drill to get all the way through in one go. Perfect. Set up for the final operation now. This requires an oil hole to be drilled at 60 degrees to intercept the hole that runs down through the part. So to establish where that needs to be, we have the distance from this face to the starting point of the hole here. So what I've done is found center just using an edge finder as I did before between those two faces. I have this set up, this mini vise at 60 degrees, which I simply set up using an angle block. This just being an oil hole doesn't have to be super accurate, it just needs to intersect with the plain part of the hole that runs down through the center of the part. So finding center in the Y direction there, that was easy, and to locate this edge, all I'm doing is using this center drill as a pointer, which I think will be more than adequate for this. If this was a really accurate feature, that had to align some other parts, then I would take a different approach to it, maybe use a tooling ball located somewhere so that I could accurately locate some features. But for this, I think this will do the job very nicely. So the plan is to use a 1/8 inch end mill to just put a small flat on this surface. Then I'll come back in with the center drill and then come in with the 3/32 drill and drill the hole. And that's it. Very easy. So let's give that a try. A little bit more explanation of the angle thing. So here on the drawing is the oil hole at an angle of 60 degrees to the center line of the part. So I've sketched that out over here. So there's the center line of the part, there's our oil hole, and that's the 60-degree angle. So, and the dimension we know is the start of the oil hole to this face. So we know this distance here, and as we've got it set up in the machine, we need to know this distance. So that's just a little bit of basic trigonometry, and the triangle we're interested in is this one. That's this triangle here, badly sketched. There's our 60-degree angle from here. There's our 5/16 line, and we need to know this distance, which in trigonometrical terms is the opposite of that angle. So that's very simply the sine of 60 degrees, which is 0.86602 if I remember right, multiplied by 5/16 to give us the dimension that we need there, which, as I recall, was 0.2706. This was just my scratch drawing that I made to make sure I was setting up my vise correctly. So anyway, that's where that dimension comes from. I wouldn't normally use a drill chuck to run an end mill, but all we're doing is just making a small flat so that the drill doesn't wander. Beautiful. Here it is. Completed part. Very happy, very successful. That little angled oil hole has gone exactly where it should. Can't quite make it show up. You can just about see it there. But that intersects perfectly with the other passages. This machining all worked out very nicely. Now let's take a look at it with its mating part. That's a lovely fit. That's where that goes. And that slides up and down in this bore as the crankshaft rotates and the connecting rod moves this up and down. So, very happy with that. And let's have a look now at the fit on the end of the connecting rod. Finally. Very nice. Well, I think we'll call that a success. Well, yet again, thanks very much for watching and following along. Do appreciate it. If you have any comments or questions, please go ahead and put those in the comment section below. But in the meantime, stay safe and well. Get out to your own shop whenever you can and make something fun. And all the very best. Bye for now.